Okay, so this is math board number 7. Given the 2 points, 0, 2 and 2, 4, find the slope of the line through these 2 points. So the slope is the change in y over the change in x. Gets us back to our fun formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here is my x, y, my 1, 2, oops, nope, my 1, 1, and my 2, 2, right? So I'm going to have y sub 2 minus y sub 1, so that's going to be 4 minus 2, divided by my x sub 2 minus x sub 1, 2 minus 0. That's going to be 2 over 2, which equals 1. Okay, so here the slope is 1. Use y equals mx plus b to write an equation of the line going through these points. So I have y equals mx plus b. We just figured out that m is 1, so y equals 1x plus b. And then what we need to do is figure out b if only we had numbers to put in for x and y. Oh yeah, we do. Oh, actually, well, I'll come back to that in a second. Okay, so here is my x and here is my y. So I'm going to have 2 equals 1 times 0 plus b. 1 times 0 is 0, so b equals 2. So then I have y equals 1x, I don't really need to have the 1, plus 2. Incidentally, this is what I was going to say, but I thought, oh, I'll just finish showing you the work. This is 0, 2, and you always have the y-intercept when the input, or the x, is the value of 0. So since this is 0, 2, I actually didn't need to do any of this work. I could have just said, oh yeah, b is equal to 2. Number 2, given the points 1, 3 and 4, negative 3, write an equation of the line going through these 2 points. Well, first thing we need to do is figure out the slope. So m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. I'm going to have negative 3 minus 3 divided by 4 minus 1. So negative 6 divided by 3, which is going to give me a negative 2. But that's not what they asked for. They didn't just ask for the m, they asked for the equation of the line. So while you have to figure out the m, you still have to, that's only the slope. You still have to come up with an equation. Okay, so since I'm given 2 points and neither one of them is the y-intercept, I am going to go ahead and use the y minus y sub 1 equals m times the quantity x minus x sub 1. So then y minus 3, or you could say y minus negative 3. Choose one of them, but use the 1 for both the x and the y. So y minus 3 equals, the slope was negative 2, times the quantity x minus 1. Okay, you also could have fallen back on this and figured out the slope-intercept form, right? This is called the point slope form because it tells us a point and the slope. But you also could have just simply said y equals negative 2x plus b, 3 equals negative 2 times 1 plus b, negative 2. And I add 2 to both sides, so b equals 5, right? So then the other equation that you might write is y equals negative 2x plus 5. Okay. Determine, if any, the point of intersection of the line N1 and in the line 2 above. Write it as an ordered pair. So what we're going to do is we have 2 equations. We have y equals x plus 2 And we also have y, well, either one. Y, I'll just use this since I went ahead and figured it out. Y equals negative 2x plus 5. What this is asking is if these lines will cross. Basically, it is a system of equations, and they're asking us for the point of where they cross. So you can graph them, right? You can use substitution, or you can use elimination. This is one of those times where it says y equals and y equals. It's really easy to take this and substitute it in right here using substitution. And if I did that, I'd get x plus 2 equals negative 2x plus 5. Okay, then I'm going to, I'm already thinking of 3x in my head. So then I would get all my variables on the same side. So I subtracted x because then I'm eliminating it from this side, and I got 2 equals negative 3x plus 5. Then I need to isolate this, so I'm going to subtract the 5 from both sides. Divide both sides by negative 3. I'm going to get x equals positive 1. So that's part of where it crosses, right? When we have in a system of equations, we need to know the point where they cross. I just figured out x, but now I need to figure out y. Using either one of these, I'll use the top one, substitute in that value that you got for x, which is 1. So the point they cross is at 1, 3. And the way we can check that is if I substitute the 3 in, right, because that's y, and the 1 in, both sides should be true. So if I put the 1 right here for x, 1 plus 2 is 3. Oh, and y is supposed to be 3, so that works. Down here, if I have negative 2x and I substitute in the 1, that would be negative 2 times 1, which is negative 2. Negative 2 plus 5 would be 3. Oh wait, yeah, y is supposed to be 3. So this is a solution of where these two lines would cross. Graph the lines from 1 and 2 and label the point of the intersection. Okay, so I'm going to kind of cheat because it tells me the 2 points, right? So 0, 2, 0, 2, and 2, 4. All right, so there's those 2 points. So now what I'm doing is like, okay, so that's going to be to the right by 2 and up 2. So to the right by 2 and up 2. I'm just kind of keeping an eye on this. Or 2 to the left and down 2. So I'm just making sure that I'm kind of, without plotting a whole bunch of points, just making sure that the line I draw is accurate. That's pretty good. And then for my other one, it tells me the points were 1, 3, so 1, 3, and 4, negative 3, 4, negative 3. So then there's, okay, and look where they cross at 1, 3. What is another name for the point, for the intersection point? It's also called the solution. The solution of the system is fine. Of the system. Suppose that lines 1 and 2 turned out to have the same slope, which obviously they don't. What would their point of intersection be? Well, if their slope is the same, the lines are parallel. If the lines are parallel, then there is no point of intersection. And this would be no point of intersection no solution, lines parallel. Last one. In a text, your friend asks you to meet her at the lake. Oh, that's so nice. Both of you start heading there at the same time on your bikes, but she's already 3 miles closer to the lake than you are. The graph below shows the distance she is traveling. So here's her distance that she's traveling per hour. She starts 3 miles closer, so her y-intercept, her starting point, is already 3 miles closer to the lake. You decide that you want to catch up with your friend before making it to the lake. So which point on the graph will you be able to do so? So you're traveling at 8 miles per hour. So for every hour, you've gone 8 miles, but you are not this 3 miles closer to the lake that she is. So she starts right here because she's 3 miles closer to the lake. You start right here. And then it said for every 8 miles, for every hour, you go 8 miles. So here's 1 hour. Here's 5 miles, 6, 7, 8. And then after another hour, you go up to 16 miles. After another hour, you would be at 24 miles. 20, 21, 22, 23, 24, roughly. Kind of eyeballing it. Okay, so it says, at which point on the graph will you be able to do so? In other words, where will you be able to catch up with her? So it looks like right in here is where it crosses. Okay, and that is about 1.5. And yeah, about 12 miles. Okay, so after 1.5 hours, so it says at which point on the graph will you be able to do so? So here we go. This is the name 1.5, 12. So at 1.5 hours and 12 miles into your trip, you'll be able to catch up with her.